Hello, today. Yes, in this special class, we'll be looking at one of the theorems of um, triangle, especially if we have an equilateral triangle. We're going to show that all the sides are 2 units, and any line that crosses from any of the vertices that touches these 2 lines is root 3. So what we are trying to say is that once you have an equilateral triangle, all the sides here they are 2 units, and this from here, that is the altitude, is root 3. So that's what we're going to show in this proof using both geometric and algebraic process. Stay tuned and let's go about it. Imagine if you have an equilateral triangle, it means that all the sides and all the angles are the same. So that is, if we draw a line from here, as I drew this line, if we draw this line here to here, and we name this place as D, okay? And we name this place as D. Then if we also draw another line here, from this vertex here, B, okay, to the middle of AC, let's assume this line is also D. Then if we draw another line here, from C to meet AB, this is also the middle, let's assume it is D. Okay, we assume it is D. So because this line here, the line AB is equal to the line BC is equal to the line AC. That is our equilateral triangle. All the sides are equal. Okay? Now, if all this AB equals to BC equals to AC, they are the same, then the length BC, for instance, is made up of the length BD plus the length of BC. So BD and BC, they are equal. So the length BC, it is also true that the length BC is 2, you can say it's 2 times the length of BD. Since BD and BC, they are the same. Okay, they are equal in length. Alright, so assuming we decide to move to cut one part of this triangle, we decide to bring out one of the triangle. Let's assume I'm bringing this out. Here is A, here is B, and here is D. Okay, so now this triangle here is a right angle triangle, and by theorem we could say that the length AB square is equal to the sum of the length BD square plus the length AD square from our Pythagoras. Specify that once you have a right angle triangle, the square of the hypotenuse, that is the side facing this right angle, is equal to the sum of the square of the 2 other adjacent sides. Alright? So if AB square is AB square, then AB square is equal to BD square plus AD square. Here we said that BC is equal to 2 times BD. Since AB, BC, and AC, they are equal. So we could say that in place of AB square, we could replace it with 2 BD in brackets square is equal to BD square plus the line AD square. So we are trying to find what does this altitude AD represent. Because if AB, BC, and AC are equal, it is also true for me to say BC, since BC here is 2 times BD, so in place of BC, which is also the same thing as AB, I can represent it with this expression. So if we square this term here within the bracket, this becomes 4 times the line BD or square is equal to the line BD square plus the line AD square. So now it is true, if we move this one to the left hand side, this becomes 4BD square minus BD square is equal to line AD square. Now 4BD square minus BD square, that gives 3BD square. So is equal to the line AD square. Now all we need to do here is simply to divide both sides. Let's divide both sides by BD square. Divide both sides by BD square. So that here this becomes 3 is equals to, because of BD square here, we book off with BD square here. So what we have here will now be the line AD square divide line BD square. So, but what we are looking for, we are just looking for the line AD. So that means we need to get rid of this square. So by so doing, what we need to do, we take the square root of both sides. So remember, this one means divide by 1. So if we take the square root of both sides, this becomes root 3 divide root 1 is equal to the square root. We take care of the square on the right hand side. This is line BD square. So here we have a root 3 divide 1 is equal to the line AD divide line BD. So by equivalent it means that line what? AD is equal to root 3. Then the line BD is equal to 1. Line BD is equal to 1 from here now. So if you compare here, this is to this, while this is to this. So with that, we are able to know that this length here, AD, which is the same thing as BD, which is the same thing as what? BC, they are equivalent to root 2. But if you recall, how do we not know that this length AC, AD, or BC is 2, like I stated before? Now, we have also stated here that the line BC, we stated here that the line BC is equal to 2 times, look at it here, 2 times the line BD. The line BD is 1, that means 2 multiply 1. So the line BC is equal to 2. Also know that because this triangle here is an equilateral triangle, all the sides are equal. A, B, B, C, and AC, they are the same. So that's why it is true that all the sides of an equilateral triangle, they are 2 units each, and any line that cuts it from any of the vertices and cut this triangle, meet it at this midpoint here, is usually what? Root 3. So this line here is also what? Root 3. This line here is what? This is also what? Root 3. This is the algebraic and the geometric proof to show that given an equilateral triangle, the sides are 2 units each and the altitude is root 3. Please, if you find this piece of information very useful, let me like, share, comments, and also subscribe and follow my Facebook page. See you in my next masterclass.